We're going to be talking about linear and absolute uh, inequalities today. So here we're going to graph each inequality and write interval notation as well for the inequality. So we have x is greater than 7 but less than or equal to 6. So -7, 6. Now it's greater than 7, so parenthesis, but less than or equal to 6, so a bracket. So it would look like this, and then -7, 6. So you can see how using this different way of graphing the inequality will help us write our solution in interval notation. Okay. X is less than or equal to 4. So here's 4, and less than or equal to would be a bracket, and going less than. So then it's going to be -infinity, 4 with a bracket around 4. And then x is greater than -2. So again, we're going to draw right, -2. Now greater than means just a parenthesis because 2 is not, -2 is not included. So parenthesis -2, infinity. Right, now solving inequalities. This is sometimes a little bit tricky because we really have three sides. We have the left side, the middle side, and then the right side. So we're still going to try to get x by itself, so we're going to add 8, but we're adding 8 to every side. So now it's going to become 5 is greater than or equal to -5x, which is less than or equal to 10. Now if you divide everything by -5. Okay. When dividing by a negative number, we flip the inequality sign. So when dividing by a negative number, flip inequality sign. Inequality sign. So now it's going to become -1 is greater than or equal to x, which is greater than or equal to -2. Now, we usually, when we're doing domain and range or writing interval notation or graphing inequalities, we want the smallest number on the left and the biggest number on the right. But right now, that's reversed because -1 is bigger than -2. So watch what I'm going to do. I'm going to flip them. So I'm going to put -2 first because it's smaller. But my inequality sign is x is greater than or equal to -2. So you see how x. So you see how I flipped that, but it meant the same thing. Okay. We have right here x is greater than or equal to -2, and here the open part of the inequality, the x is greater than or equal to -2. But we also just say that x is less than -1. So yes, this changed again. And the reason, again, we're changing that is because we want the inequality to be written in order. The left number is the smallest, the right end is the largest. Because now that's going to make graphing this a lot easier. So we have -2, -1. X is greater than that, greater than or equal to, so we're going to do bracket, but less than -1. So it's going to be everything in between. So I know that can be a little bit confusing, so you just got to be very careful that when you're moving your signs around that you're still saying the same thing. All right, now absolute value equations. First, you need to manipulate the equation to get the absolute value bars by itself. Luckily for us, both of these already have the absolute value bars by themselves, but if you need to manipulate, add stuff, subtract stuff from both sides, divide stuff on both sides, we want the absolute value bars by themselves. Once you have that, you split this up into two separate equations. 3x plus 7 equals positive 4, and then 3x plus 7 equals negative 4. And what this does is it changes just the sign of the the right side, where we go positive 4 and negative 4. The inside stuff stays exactly the same. The absolute values bars go away. We leave that left side alone. We change the right side. And then we solve them separately. Subtract 7 from both sides. We get 3x equals negative 3, and x equals negative 1. Then in the other one, again, subtract 7 from both sides. We get 3x equals negative 11. Divide both sides by 3. X equals negative 11 over 3. So then you want to, again, check both of these in our equation, the original. So to do absolute value, we do alpha window. The first one is abs. 3 times negative 1 plus 7, and we hope we get 4. Okay? And then we'll do this again. 3 times negative 11 over 3, close parentheses, plus 7, and we also get 4. So both of these are viable solutions. When we have absolute value equations, we could have no solutions, one solution, or two solutions. Now, letter B is a bit tricky because we have a variable on that other side and we have an x squared. So it's going to be x squared minus 6 equals x, and x squared minus 6 equals negative x. And we're going to solve both of these separately, and they're both quadratic, so we could have two solutions for each of these. So we could check, we would have to potentially check maybe 4 solutions here. So minus x from both sides, we get x squared minus x minus 6 equals 0. And then we factor that to x minus 3 times x plus 2 equals 0. So our possible solutions are 3 and negative 2. Those are our possible solutions. Now I'm going to solve the other one first before checking these, because maybe there's going to be some overlap. Maybe this other one also has x equals 3 as a solution, but it's possible that it doesn't. Here we're going to add x to both sides, so x squared plus x minus 6 equals 0. And then we're going to have to factor that. We get x plus 3 times x minus 2 equals 0. And then our possible solutions, are going to be negative 3 and positive 2. Now, we're going to check these in the calculator. We got to check again all 4 of them. Back in the original. So I'm going to check the positive ones first, just because it's easier to go back and change them. So we had positive 3 squared minus 6, and we want it to equal x. So we plugged in 3 for x, so when we hit enter, we hope it equals 3. Okay, it does. So x equals 3 is a solution. Now we're going to go back up here and change it to x equals positive 2. And then we hit enter, we get positive 2 as well. So we know that these are at least 2 solutions. Now, when we type in the other ones, okay, you don't really have to do that for 2 reasons. One, because negative 2 squared is going to give you the same thing as positive 2 squared. The difference, though, is we can't have the absolute value equal a negative number. So when we plug in -2 for x on the right side, it's going to give us no solution. And when we plug in -3 for x on the right side, again, your absolute value can't equal a negative number. So we know x equals -3 won't work. If that didn't make sense, you can just go back and plug them in. You can plug in -2 and -3, and you will see that you will not get the original x value you plugged in. So we're bringing back solving quadratics, but also throwing absolute value in as well. So thanks for watching. Make sure to like this video and subscribe. Right now, on the next page, we're going to talk about absolute value inequalities. Because remember, absolute value means the distance away from 0. So if I say that the absolute value of x is less than 5, what that means is that the distance x is from 0 is less than 5 units, but that could be on either side. Because if we look at a number line, okay, there's 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So anything in this range has a distance from 0 less than 5. Because if there's my 0, okay, -4, that distance from 0 is 4, which is less than 5. So what we have to do with absolute value, just like how in solving absolute value we had 2 equations, for inequalities we would have 2 inequalities. We would have one that's x is less than 5, but then one that x is greater than -5, because that would give us a distance that is less than 5 away from 0. And we would have to write this as -5, 5. Now here, absolute value of x is greater than 5. That means the distance from 0 is greater than 5. So if we have our number line here, we want everything outside. We want this way. Because all those numbers, yes, they're smaller numbers, -6, -7, so on, but the distance away from 0 is bigger than 5. So we'd want x is less than -5, but also everything over here where x is greater than 5. So you can when we solve the absolute value equations, when we said the absolute value of x was equal to 5, we would say x is equal to -5, and x is equal to 5. We do the same thing. We would have a positive one and a negative one, but notice for the negative one, we switched the signs. So our answer here, our solution, is going to be -∞, -5, and the way we write and in symbols is this U, which stands for union, 5 to infinity. So this means and. So our solutions are from -∞ to -5 and 5 to +infinity. So if we look down here, we have some examples. First step is always to isolate the absolute value, get it by itself, and then we're going to switch it to 2 equations, one positive and one negative, but for the negative one you have to flip the sign. So we have 3x plus 4 is greater than 6, and then 3x plus 4 is less than -6. And then you'd have to solve these. All right, in purple we get 3x equals 2, or sorry, not equals, 3x is greater than 2, then x is greater than 2/3. And then the blue one, subtract 4 from each side. 3x is less than -10. Divide both sides by 3. 3 is less than -10/3. So then on our number line, we have negative 10 thirds and positive 2 thirds. And it says x, this should say x. X is less than negative 2 thirds. So parenthesis, and everything smaller than negative 2 thirds. And then x is greater than 2 thirds. So here's 2 thirds, parenthesis, everything bigger than that. So we would say from negative infinity to negative 10 thirds with parentheses and 2 thirds comma infinity. Right. This one, the absolute value is not by itself, so the first thing we have to do is add 4 to both sides, and we get the absolute value of 11 minus 2x is less than 3. Now we can split this up into our two two inequalities. Whoops, this one should be greater than the negative. So we're going to solve the purple one, subtract 11 from both sides, so negative 2x is less than 3 minus 11 is negative 8. Divide both sides by negative 2, we get x is greater than 4. Then for the green one, subtract 11 from both sides, we get negative 2x is greater than negative 14. Divide both sides by negative 2, x is less than positive 7. Because remember, when you divide by a negative sign, or negative number, you flip the inequality sign. So then 4 and 7. We have x is greater than 4. So here's 4, parenthesis, and greater, so everything bigger, but x is less than 7, so parenthesis at 7, and going to the left. So our solution, our interval, is 4, comma 7. All right, then let's get the third one. We have 2 times the absolute value of 2x plus 3 is less than or equal to 6. So divide both sides by positive 2. So this one has less than or equal to, so when we graph them, we're going to use brackets, and when we write our answer in interval notation, we're also going to use brackets. All right, so now we have 2x plus 3 is less than or equal to 3. And then we have 2x plus 3 is greater than or equal to negative 3. So we have 2x is less than or equal to 0 once we subtract 3 from both sides. X is less than or equal to 0. And then over here we have 2x is greater than or equal to negative 6 when we subtract 3 from both sides. And that gives us x is greater than or equal to negative 3. So we're going to draw our graph. We have negative 3, and we have 0. So we have x is greater than or equal to negative 3, so a bracket at negative 3, and we want everything bigger than that. But then we have x is less than or equal to 0, so bracket at 0 and everything less than that. So we have negative 3 comma 0 as our answer. All right, so the last one, we have to get the absolute value bar by itself, so we'll subtract 4 from both sides. So we have the absolute value of 2 over 5x minus 8 is greater than or equal to 8. Now that the absolute value bar is by itself, we can split this up. And then the second one is going to be 2 over 5x minus 8 is less than or equal to negative 8. Right, so then we will solve these. The blue one, add 8 to both sides, so 2 over 5x is greater than or equal to 16. Well, then we have to multiply both sides by the reciprocal, 5 over 2. And when we do that, on the left side, we get just x is greater than or equal to, and then 16 times 5 over 2 is 40 if we type that in the calculator. So x is greater than or equal to 40. Now the red one, add 8 to both sides, 2 over 5x is less than or equal to 0. Well, that's nice because when we multiply both sides by 5 over 2, we're still going to get 0. So now on our number line, this one's going to look different. We have 0 and 40, and x is less than or equal to 0, so bracket, but anything smaller than 0, and x is greater than or equal to 40, so anything 40 or bigger. So we have a range on the inside that x cannot be, but we are unbounded on the outside. So we have negative infinity, comma 0 with a bracket, and then 40, comma infinity with a bracket around 40. So I know that this new way of drawing these inequalities is a little bit confusing, but you're going to get to the point where you won't even have to draw them. And drawing them does help you make sure you're using the correct symbols when we write our answer in interval notation. One last thing, we have to put that U in there for the union, like both of those things could be true. Right? So thanks for watching. Make sure to like the video and subscribe.